let's look at our last section of chapter 10, 10.5. We're gonna find the area of the polar coordinate. All right. There are several different shapes, but the one I want you to focus about is the rose curve. All right. Let's look at the first theorem, theorem 10.3. This is the formula for the polar coordinate. We will go to this formula in the example, that way it will make sense to you. And theorem 10.12 is the tangent line at the pole. So it said that if you have f of alpha equal to 0 and derivative of f of alpha not equal to 0, then the line theta equal to alpha is the tangent line at the pole to the graph r equal to f theta. So let's look at my first example here. I want to find the area of, let's say, one leaf, one petal. R equal to 4 sine 3 theta. As you recall from previous section, my A here is 4, which means my radius is 4, you see. 1, 2, 3, and 4. That's my A. My N is 3. 3 is odd. It means I'm going to have 3 petals. I'm going to have 3 petals. So an angle between the petal will be 120 because 360 divided by 3 is 120. And the first petal, because it's a function of psi, will be 90 divided by n. My n is 3. So my first petal will be at 30 degrees. 30 plus 120 is 150. 150 plus 120 is 270. So that's my 3 petal rose curve. So we need to find the tangent line. Once you have the tangent line, we're going to apply into this formula to find the area. So the theorem said set f of alpha equal to 0. So I set it equal to 0. 4 sine 3 theta equal to 0. I divide both sides by 4. I have sine 3 theta equal to 0. To make it satisfy this equation, theta has to be 0 and pi over 3. Now you have to check the second condition. The derivative of f of theta is 12 cosine 3 theta. It's not equal to 0. If you put 0 in here, you have cosine of 0, which is 1. 1 times 12 is not 0. Pi over 3, cosine of 3, pi over 3 is cosine of pi. Cosine of pi is negative 1 times 12 is not 0. So it satisfies these two conditions for all theta, which is this 2. Then I can apply to find the area. Now this is the formula for the area is 1/2. I'm gonna calculate this first petal. As you can see, this first petal is between pi over 3 and 0. So 1/2, an integral from 0 to pi over 3. My function is 4 sine 3 theta square. Right here, square. I forgot the theta. Theta. All right. So 4 square is 16. 16 divided by 2 is 8. That's how I have an 8 here. And the square here is make side square 3 theta, d theta. Next, I use this formula. Sine square of u equal to 1 minus cosine of 2u over 2. My u here is 3 theta. So I rewrite this as a function of cosine. So I have 1 minus cosine. I have 3 theta, so times 2 is going to be 6 theta divided by 2 d theta. All right. Now I reduce the 2 and the 8. I got the 4. And I break this into 2 parts. One is just 1. One is just cosine 6 theta. The cosine 6 theta, I need the 6, so I have to multiply by 1/6 here. And then I take an integral of 1, which is theta. An integral of this one, it's just sine 6 theta. Lower bound is 0, upper bound is pi over 3. Now if you substitute 0 in all this, you're just going to get 0. So I end up with 4 pi over 3 minus sine 6 theta is pi over 3 over 6. And this is just 0. So I end up with 4 times pi over 3, which is the area. This is the area of 1 petal. If you need 3 petals, then you just multiply by 3, the symmetry. All right, so let's look at more example. Hi everyone, let's look at one last example for this section. Again, this is our last section of chapter 10. Anything I did not cover, you don't have to worry about it, alright? So it won't be in the test. So let's look at this one. Find the area of the region of R equal to 3 cosine 3 theta. The last one we did the sine, now we're going to do the cosine. 3 here is my A, which is the radius, so I'm going to have one circle, 2 circle, 3 circle, just the radius getting bigger. And here is 3. 3 is odd, so it means that I'm going to have 3 paddle. And each paddle will be 120 away from each other. For cosine, the first paddle will start at your x-axis at 0 degree. So that's the first one, 0. The next one is 120. The next one is 240. There are 3 of them. Now I need to find the tangent line. After I get the tangent line, I plug it in here to find the area. So the tangent line, you set the equation to 0. So I divide both sides by 3, cosine of 3 theta equal to 0, which means that my theta will be pi over 6, pi over 2, and 5 pi over 6. Next, I have to take derivative of f of theta. I take derivative of f of theta. I have 9 sine 3 theta. And you need to check each one of them that this is not equal to 0. I forgot 0. Not equal to 0. That's the theorem right here. So make sure in the test show me y is equal to 0, y is not equal to 0. Show the complete word. But if you check it's not equal to 0. So from here we can apply the area. Now since they have 3 paddle, you can pick any one of them. Alright, so what I did, I picked the first one. The first one is between pi over 6 and negative pi over 6. You don't have to pick this one. You can pick this one or the third one. That's okay. But you should get the same answer. Some people might do half paddle, which means from 0 to pi over 6. Once you get that area, you know the full paddle will be double of that. That's okay too, however you're comfortable. But make sure it's clear to me which paddle you pick. You pick half or the whole thing. And draw the picture and shaded area for me. In this case, I pick the first paddle here from pi over 6 to from negative pi over 6 to pi over 6. As you can see here, I take an integral of 3 cosine 3 theta squared d theta. 3 squared is 9, so I have 9 over 2. Now 3 cosine theta I use this formula again, similar to the one we did in the last example. So I end up with this whole thing. Then 2 times 2 is 4, and I bring it outside in integral. Now I break this into 2 parts, 1 and cosine 6 theta. So in integral of 1 theta and integral of cosine 6 theta. I need the 6, I have to multiply by 1/6, and then I take an integral of this. Substitute the lower bound and upper bound. You will end up with 3 pi over 4. This is represent 1 paddle. If you want the whole thing, multiply by 3. And if you only do half of the paddle, you need to double it to get the full paddle. Alright, so we finish. Yes. I hope I see you next semester. Alright, bye.